So my home screen, right? This is like the website I wanted to track people's hormone levels. And when I start, and you can literally just upload your medical report. I'm not sure whether it's really analyzing this correctly according to the instructions I gave, but this is something crazy that literally gave me some of the results analyzing, and it's
But
gave me this.
on what data is analyzing? You don't know that, yeah?
I gave some instructions about the hormone stage and what kind of blood test needs to be done there. Yeah, so I gave some of the prompts on around how to determine the hormone levels need to determine by certain thyroid functions, reproductive health indications. Yeah, and it gave me. So that this part, I think it faked it because the integration cannot be so quickly. So I didn't really connect to any devices. But then when I choose my mode, for example, I change it right now. Okay. It does give me some of the results is definitely shown based on my instructions on what kind of stage it is. Yeah.
Wow, this is super cool. Does it use OpenAI or one of these AI models to analyze the report?
I can say history as sorry, can you repeat your question?
Does it use an AI model to analyze the report, or does it use an OCR? Do you know?
What is OCR?
Optical character recognition. It's just a way to turn your PDF into text and just create without any intelligence. No AI model. Does it use an AI model or no? That's the question.
I don't know. How can I find out it? Because this is like really new. Actually, it doesn't take a lot of prompts for me to get here, honestly. Yeah.
Okay. But if you didn't put any
goes into like real AI model. Yeah, I didn't.
But it says AI scoring. I can see AI insight, cycle phase, you scroll. Yeah, see AI powered intelligence. So it does say it uses AI. So maybe, but
it
did
might
you
be
give?
lying.
Okay, so then it's a dummy thing. Yeah.
It's hard to say because my instructions I did give lengthy medical instructions in the beginning. Okay, I couldn't find it. It's very long.
Okay.
Yeah, but
Yeah,
I
we
don't
can
think it's
investigate
AI
it.
model because I didn't specify like what AI model. Here you can see all the code sources and yeah, so all integrated.
Cool. Yeah.
Can you find it here?
So the best way to find is to ask chat. Like in the chat, you ask what AI model is, how is my data being, how is the analysis being done? Does it use an AI model or not? That's the easiest way to ask.
I suspect it only helps you to build and it doesn't give you communication much. Yeah.
Yeah, that's the issue, right? Each tool has its pros and cons. So if you get very comfortable with one tool, that's the best. But yeah,
So
I
I'm
don't see
wondering
like
if I can export this because it integrates with it comes in. It integrates with GitHub, right? So I can export it to Cursor and then analyze from there.
yeah, of course. So you see, it uses, if you scroll up, it uses an AI model. Scroll up a bit. No, not this much, a little down. Yeah, see, step 2 AI analysis. It uses Blink AI generate text with the GPT-4o mini model, analyzes extracted text. So yeah, it uses an AI model, basically.
Yeah, there's no like special medical AI layer, right?
No, it's
Yeah. So yeah, the most
very cool.
would be like the AI model.
Yeah.
Let's just do that.
This is super cool. Yeah, let's we have our one-on-one, right? Let's dig more and find out like what's happening, how does it work, and I can suggest like how to optimize it. Yeah.
Okay. Is it like from
Awesome.
this experience, I have spent 2-3 hours on this. It's crazy when it's able to do this level. And I was wondering like what's the point to do all these things in cursor?
You will hit a limit. Like until a certain point, you can keep going this way, but the more complexity you add, the difficult it gets. Try it out. Push it as much as you can. When you hit the limit, you will know when you'll find another better tool. When you're building full stack applications, for example, I built an entire restaurant ordering experience that I can never imagine doing it on Lovable or Bolt or Blink or anything. I need.
Okay.
It's so complex. It has so many things, authentication, databases, talking to different services, using different environment variables, using webhooks. There's just so many things. So when more complexity adds, you need more control. That's the thing.
Okay.
Yeah. Cool.
Sounds
Let's
cool.
keep moving. This is going to be a bit short, but like just the essentials of what you need to know. Week 4. Show and tell, we did that already. Today, databases. So we are in week 4. We are going to touch on some local storage and database. And then next week, we'll go into authentication, how to make logged in, logged out, and then finally deploy. Week 6 is going to be like, it'll be pretty short. Database 101, right? Okay, what is a database? So far, how you've been building on your application, all your applications has no database. It stores your data in your local application. It stores in your browser. So your browser has a storage in the form of session or cookies, and all your data is stored in your browser. And that's why when you refresh your page, you lose all your data. So that's why you're not able to preserve the data for the next time you log in. So even if you deploy your application and you can see it in a URL, when you interact with it, you can see the data while you interact with it. When you refresh your page, you lose it. So to solve this problem of not keeping your data temporary, but having it up in a permanent place, we use databases. So it's an online storage system that can be accessed. So there is a certain structure with which you store your information in the database. So you usually have tables for each structure. And on the right side, you can see that usually this is the way people store information in a database. They create a table for all the users who are logging into your application. They create a table for all the orders in the example of, say, food delivery app or like an e-commerce app. They create a table for all the orders. Then they create a table for all the menu items, for example, in a food delivery app. And then they create a table for all the toppings. So it's a collection. So you can think of your application and think of what all collections exist. So I guess someone was building an app for booking a trip, right? So you can have a collection of destinations, so which will be a table. And then you can have a collection of trips made. So it will be create another table called trips. So it's a fairly sensible, logical way to think about this. It's a no-brainer. But you think of when you have more volume or a collection of the same type of data, you decide to put it in a table and you store that table in the database. That's pretty much the crux of it. The differences between,
Sorry,
yes.
sorry. Is this the JSON files we have? Is that what you're calling?
The JSON
Because
file you have is the local version.
okay.
Yeah, you're right. That's the one we are talking about. The JSON file is the one that React uses, your React front-end technology uses, and that's usually stored locally, right? So it stores locally as a JSON. And then when that JSON is put into the database, which is using a different service, like we use Supabase and Postgres, and we'll talk about that, then it becomes a permanent resource. In your database, it doesn't store as a JSON, it stores as a table. Just imagine it's something like Google Sheets. So imagine you take your data from your JSON and put it inside Google Sheets in its format, and then you retrieve again from Google Sheets, turn it back to a JSON, and then use it locally. Does that make sense?
Yeah, thanks.
Cool. So the difference between local and database is local exists only on your device. It disappears when you clear. It uses cookie and session. We just spoke about it. And your database, it lives on the internet. It is accessible everywhere, and it loads each time. Each time when you load your application, you need to bring information from the database. So how your database requests work, right? Typically in companies, in the company that I'm working in more production ready applications, your client, which is basically your application, talks to a server. A server is like an intermediary logic whose job is to just to understand what you want and then go fetch it from the database and give it back to your client. So the server is like this intermediary. It's written also in JavaScript, in React. You can write it in React, you can write it in Python, several languages. So typically the ones working on the client are front-end developers. The ones working on the server are backend developers. So in companies, if you see a backend developer, they're probably working on the server side logic. So typically when you make a request, it goes to the server. The server identifies what information you need, and then it goes to the database, pulls that information, gives it back to the server, gives it back to the client through the same route. So this is how typically databases are done. Nowadays, things have become a lot more easier that you actually don't need that intermediary server. So using a tool like Supabase, which is we're going to talk about it. So Supabase is another service that's called a backend as a service. So they take care of the server and the database together as one service. So all you have to do is just go talk to the database and get the information, right? So you have both kinds of setup. So if your application is using Next.js as a technology, you're probably going through a server. If your application is not using Next.js, probably Vite, or if you're building with Lovable, it is talking directly to a database. How do you know if your application is using a server or not? You can ask in chat. You can go and be like, okay, when I make a API call, when I make requests for the data, does it talk to a server or does it directly go get it from the database? You can ask in your chat and you'll know if you have a server in between or not. So it's useful for you to know, because this is a much cleaner way of approaching when your program scales in size. So if you have a really large program, having a collection of services, which is like there'll be one service that just fetches your user data. There will be one service that just fetches your order data. There'll be one service for each fetching logic. There'll be a service that lives in the server. So that's how they create a more organized way in bigger companies, where backend developers are just in charge of that one specific service. We, on the other hand, are going to directly talk to the database and pull our data back to our app. So there are like two types of databases that you need to know. It says simply SQL and NoSQL. SQL stands for Structured Query Language. It's the short form of it. I don't know, maybe you might, if you speak to any analytics person, anyone working in analytics, this is their like main programming language. This is what analytics people do. They try to fetch data and try to make some analysis out of it. So the difference between the databases, SQL and NoSQL, is that in the SQL, you always have it like a table. So Google Sheets has a table, right? So if you have a table, all your data will follow the same format. So every row has one ID column, one name column, one email column, and one age column. So there will be no rows that has another additional column, for example. So that's why we use a structured query language. So it has a structure and it cannot break the structure. So you store, like every user has a name, every user has a last name. So users table being an SQL table makes a lot of sense, because then you would not have to break the structure. It's like a strict spreadsheet. And Supabase, for example, is a structured database, right? The NoSQL is basically your JSON. So if you see, this looks a lot like the JSON that we had. So if you see the comparison between these two, the first one has an ID, so name, email, and age. The second one has an ID, name, email, age, and hobbies too. So the first one doesn't have hobbies, and that's fine. And this is another type of database, in the type as in in what format it stores the data. And your React application is very similar to your NoSQL, but it's not a NoSQL database. But the NoSQL database idea is to have an unstructured data. So there is no fixed structure. It can follow any format. It's like a flexible JSON, and an example is Firebase. Firebase Studio that you mentioned it uses Firebase. So Firebase and Firebase Studio, both of them are from Google. So Firebase Studio would have a direct integration with Firebase. I assume, I haven't tried, which would make like data logic databases so much easier, because you don't have to rely on an external service like Supabase, which is optional. If you want, you still could. So if you see, these are some examples. So SQL data, Supabase and Postgres SQL are like two examples of SQL databases. Firebase, this is a logo for Firebase. This is a logo for MongoDB. They are both like NoSQL database, but you will mostly see one of these four mostly used by companies. So if you go talk to a backend developer and be like, hey, what database do we use? You're likely going to hear one of these four. Or maybe there's one more option, but Postgres SQL is the most common database that used in many companies, including mine. Okay, so now just to touch on schema. So schema is what structure that you're creating to store in your database. For example, in this one, this is the schema. ID, name, email, age is the schema. So you're good. Yeah, go on.
So if I'm a backend developer, like what are my decision points in choosing SQL versus NoSQL?
Good question. So see, NoSQL gives you freedom, right? So it really depends on what kind of application you're building. If you're building an application where like optional data points are always captured in your app, for example, you have a form and your form data is you want to store only your form data, an example. So your form data can be varied, right? So some fields could be optional, some fields could be mandatory. So your structure of the data of each form submission could change. But on the other hand, if you have users who are visiting your app, the structure of every user, as in the information related to each user, is the same for all users. Every user will have an ID. Every user will have a name, an email, an age. So it really depends on what data you're building, like what kind of application use case you're building. You can decide if SQL is best for you or NoSQL is best for you. But you could technically interchange, right? So you could store this information in a NoSQL. People have built that. So you can build applications on full stack applications on Firebase without using SQL. There's no problem. It's just that SQL is faster because the structure is defined. NoSQL is a bit slower because it takes much longer to scrape through all the information, and it does like matching by name, matching by email, that sort of stuff. And when your complexity of your data increases, you'll have to write your own logic in terms of how to go find the right data within your entire like pile of data. So NoSQL will get more complex as you get larger. SQL is super scalable. SQL is like the gold standard for building applications because it has a defined structure. Programmatically, it's much easier and faster to go pull out what is the user, like the 331st user or 3,333,000 user. It's easy to pull out from an SQL. But on a NoSQL, if you have 10,000, 50,000 data, it'll struggle. It'll take a long time.
Awesome. Thanks.
So yeah, schemas. Schema is a blueprint for a data structure. So obviously you might have seen in JavaScript we spoke about data types. Similarly, you have a string, a number, a date, Boolean, or an object. So you have these types of data that you can store in your database. So with this, you will typically define what information related to a table you need to store, and you will define its schema. For example, users is a table we need to store. So this is how SQL code will look like. You're never going to have to code, but AI will code for you. But AI will create a table for you using this command. So it'll say create table users, and ID will be a serial primary key. So it will be a non-duplicate key. So you can only have one key. There'll be a name, there'll be an email, an age, and created it. And so each one has a data type. Character means it's just like a variable character. You define how many characters at most you want to have. So yeah, there are different types of definitions you can write to create that structure around how you want information to be stored in your database. So let's jump and show you like directly a demo, right? So I'll go open let's see, what do I open? Okay, let me open Lovable. I'm out of credits. So I'll create a new account just quickly. Okay, so let's try to build like a very simple app and connect to a database and see. So I'll say build a page for adding groceries to a cart, the simple page for adding groceries to a cart. So what we're trying to do is just see when we add items to a cart, if you refresh the page, the cart items should stay. That would be the expectation when you're on a website. But if you don't connect to a database, if you refresh the page, the items would disappear. So we will I'll show you an example of what it looks like when you refresh, what happens, and then when you connect to a database, what happens, and how we connect to a database. So we just need to give it 1 minute. Okay, it's generating. Yeah, I realized it creates like images of all the items on the page. So that's why it's taking a little longer. So until this loads, maybe I can share another like little interesting thing. If you understand how AI works, right? Like you have an LLM, like there's like your ChatGPT or Anthropic or whatever, and there are these tools that the LLM can use to achieve their goals. That's why you see the 6 tools used. So the tool is basically the AI model is using generate image tool, which would have been provided by Lovable to create images. And it uses this tool to create an image that it will display for us. See, all of this is created by this tool, basically. Yeah, that's just another like FYI. Okay, tell me if you can see my screen. So if you go here, let me add this, and I'll say add to cart. It gets added here. But when I refresh the page, it would obviously disappear. I can also publish it so you can see in the live version too. So I add here, you can see when I refresh, it's gone because this data is not stored in the database. So now how do we store it in the database? Thankfully, if you're using Lovable, the process is slightly different if you use Lovable versus if you use Cursor. I'll show you both, but the underlying concept is the same, right? The approach is slightly different. So you have a button here that says Manage Supabase. So we just have to connect this, click this and say Connect Supabase. And what that's going to do is just open this window and just say Connect Supabase. I already logged into Supabase. So it's just, okay, if you're not logged in, you just go to supabase.com and create an account. And when you're logged in, it will automatically pull out your account and just authorize your Supabase. That's it. So once you've connected it, just give it 1 minute. Okay, so this is my workspace. This is my organization in Supabase. Let me open supabase.com to show you. So when you register, when you sign up on Supabase, you will be asked to create an organization. And within organization, you can create projects. So I created these 2 projects earlier just to explain it to you, but I'm going to delete them so I can create them from scratch for you. Delete project. Yeah. So now what we are doing is, sorry, 1 second. Let me delete this also. Okay, so I have absolutely no projects in my Supabase right now. It's just clean. When you sign up, you'll see the exact same screen. So once I've connected, I'll just say continue. And it says currently there are no new projects. So let's create a project and it'll automatically open the screen on Supabase. And we are going to say Lovable to Supabase. You can call whatever your application is. Just type in a generic password, a database password. It doesn't matter. This is just for your another added level of security. And pick the region that's closest to you. Because what happens is it sends requests. So if you pick like from the US, the request would take much longer. But we are talking about like fraction of milliseconds. So usually it's better to pick the one closest to you. And also EU has all these data protection laws. So I would always pick EU. Okay, when you're connected in database, you know that this is the name of the project. That's mainly what we need to know. So when I went back to Lovable, it automatically detected that I'm connected to Lovable to Supabase and I just say connect. So when I've connected this, like pretty much your Supabase is connected to a project, but that's not it, right? So because all we did so far is to just connect the 2 tools. But if I still go and open the app and still do this thing and refresh, you'll still lose the data because we only connected it, but we didn't do all the things that we spoke about in theory, where we have to create a table. We have to go store all of this inside the table. So now the question is, how do you put this data? How do you put this cart data into the database, right? So here's where you need to understand, like the understanding of theory helps you. So you'd say something, instead of saying, go put all the cart information into the data, into the database, you can say something slightly more technical. You can say, create a schema for storing the cart items. And as soon as I add items to the cart, store it in the database. The only thing you added from what we learned is that you're creating a schema first, and then as soon as I add the item, so when does it have to store the thing into the database? As soon as I add the item. So when I add items to cart, so you can even go so far and say, when I click on add to cart, store it in the database, right? This is as simple as it gets. I want to also specify one thing, that I want to say there is no users here, because typically when we are doing something like this in applications, there's usually a signed in for a user, so you know which user is adding things to the cart. Because right now we are not having users, it's better to specify that here, right? This application will not require authentication to store in the cart. So we are just specifying that, because otherwise it just assumes that we need to create an authentication and it'll throw you an error saying, oh, we cannot add items to the cart, the user is not logged in. I've tried this once, that's why I know. So I'm just like very specifically saying this will not require authentication. And it's as simple as that. So now Lovable is connected to Supabase. So Lovable will write all the SQL language that needs to be written to create this table. It will understand what data structure you need in the cart. It does all of that for you in the backend. And imagine this was actually manually written until now. But now all of this, now it went and created this SQL. So it created this table called cart items, and it said, okay, this is the ID, this is the session ID, it's a product ID, a product unit, quantity created at. See, it looks very similar to what we saw earlier. So it created all of this. There's a lot happening here. Not only creating of the thing, it adds an index. The index is just like an auto incremental number. And then it adds like some security level permissions, like who gets to access the database and all of that stuff. So you're never going to have to like do any of that, right? So I'm just going to say, okay, I've reviewed the SQL, looks good. So yeah, this is, you're not going to do much here. You won't understand exactly into the details. Just this is the main thing for you to review. If it looks good, if the schema looks good, what we're going to store, it's going to store the session, product name and stuff. Just say yes, it should be fine. And yeah, so it's going and it's updating the component to save items to the database when adding to cart. So it's creating a functionality over here. When I say add to cart, it's adding the function of creating it to the database. So meanwhile, I'll show you in the database. If I go into the table editor in Supabase, it created this cart items table. You can see earlier this table would not have been there before we typed that. And right now it's empty, right? You don't see any data here, but you can see the table. You can see the ID, the session ID, the product name, product price, and all of that. But now when I like go and, okay, so it's done, right? So when I go open this app again, and this time I select the thing and I say add to cart. Now you might have noticed it took a split second longer to do because it spoke to the database. And if I refresh here, you can see that this information just got added to the cart. So it got added to our database. So at any point of time, if you refresh, I haven't written the logic for it to load the data when I refresh. So it might still not refresh, but now it's easy to do because now I can be like, when I refresh the page, always check for current cart and display it. So yeah, when you do that, basically I might run out of credits, but let's say if it does it, so it'll go pull that information from the database when you refresh the page, and then it will get this value, and then it'll go put it in your cart. That's basically how you talk to a database. Now I'll show you the same thing. Yeah.
Good question. So let's assume that I have a cart, right? And I refresh the page, whatever, and then I make a different cart. So I would have two rows in the database, right? How do I write the logic of which one I should be pulling? Because we don't have authentication.
Good question. So
Yeah.
typically we link it to a user. That's why that's the typical behavior, because as a logged in user, you always have only one cart, right? You always have like, you cannot have multiple carts. That's the typical behavior in most food delivery applications. So if I go to Volt.com, for example, you can see that. So I can only create one cart. So whenever I'm fetching, it won't fetch like multiple things at once. This problem will not exist if we had user level filtering. Because we don't have user level filtering, the carts can be created by anyone. This is something we need to manually define in this use case. But let's see how it did. But I don't know, but it made its own decision. But let's see. So if I refresh, see, I already get the 4 cards. So it's probably retrieving the first value it found. Okay. So maybe if I add more, and it has 8 right now. If I refresh, so it's pulling the latest item basically. Right now it's following the logic that it gets the last item stored and then it shows the whole thing together. Does that make sense? Or I think it adds, so first one is product name, second one is red apple. So it gets all the items and then it adds. Looks like that's what it's doing. So it's making its own decision right now, because this is not the typical behavior of how we would load the cart. How typically we would load the cart is there are so many cart items, but each cart item is linked to a specific user. So when we refresh the page, we check which user is logged in first. We pull the cart item that belongs to that user, and then we load that cart. That's how we typically do it.
Yeah, makes sense.
Make sense? Yeah. So Lovable has made it like quite simple. Actually, there's not a lot of, we can even ask here, right? How do you pull the latest? How do you pull the data for the cart when I refresh? Is it the latest, or do you hide all the rows? So you can ask something like this, and then it'll tell you like what exactly it's doing. But while that's happening, we will look into how to do this with GitHub, or how to do it with Cursor. So let me connect my ones. Okay, I'm just going to connect my GitHub so I can download this project on GitHub. Okay, so the thing is called Grosser Grab and Go. So I'm going to download this. By the way, if you haven't done this before, this is the easiest way to open your project from Lovable to Cursor. So I have Cursor. I'm just going to file, new window, and then open project. I'm going to go to downloads and then get this. Okay, so in Cursor is a little bit tricky for the first time, but from the second time onwards, it's super simple. So in Cursor, first, let me run the application. I need to do a couple of commands, which is to install the packages. So I'll just do npm install, and then I will do npm run dev to run the application. And then I'll show you how to do it on Cursor. So let's see if everything is working. So here's the application we built on Lovable. Now you can see it in Cursor. Same, if I refresh, you still see the cart. Oh, maybe because the Supabase functionality also shipped the cart functionality. See, implement cart on refresh. So I can go back to a previous commit, run database schema migration. I'll just go to this. So I can go back to a previous commit by just copying this thing and then go back into Cursor, and I can say, or actually I can just, yeah, I can say, first I need to connect this thing, or it's going to be a few more steps before I'm able to just do that, because it automatically synced the latest thing. Connect this application to my GitHub. So I'm just first connecting the application to my GitHub and providing the URL. So it'll do that. It shouldn't take long. So it's adding this, all of this to like version history, and it's like adding, pretty much it's just connecting the remote to the local.
When connecting with Supabase, working with databases of any kind, and earlier, I guess your prompt was like create a schema for X, Y, and Z. Do you ever worry about defining the schema, or is that something that we shouldn't be worrying about?
Yes, we should be worrying about it, because if you're building something simple as what I'm showing you, the chances of error is very small. But when you're building a more complex application, there are way more chances of error, because it will not know existing schema, and it will create new schemas without understanding what's already there. So you would create two cart items table, and each time it will go store in a different table, and then you will be wondering, why is my cart not working, for giving you an example. So it's important for you to just know what schemas it already created. So you know that when you're asking, you might be like, just use that table and just store it in it. Don't create a new schema. Don't create a new table. So you can be more specific, and you will know when things are not working in terms of where AI went wrong. So AI will make mistakes, right? Does that answer your question? So it helps when your application gets complex. But for simple things, you don't have to worry. It's always good practice to go to Supabase and see what all tables exist.
So I guess maybe I have the wrong idea of schema. What I meant is not creating two new schemas, like two new tables, but more so the columns within a single table. Do we have to worry about that?
No, within a single table, like if you have a schema, first schema that says create a table, and the second schema says same create a table with different columns, your Supabase will throw an error. You cannot write two schemas that have conflicting logic. So you will first write a schema that says create a table. Then the second one will say remove this table or update this table or add these few other tables, add these few other rows or columns, that sort of stuff. Right? You cannot, if your schema conflicts with each other, it'll throw an error. So you don't have to worry about two schemas like having conflicting logic. That will automatically happen for you. But what you need to worry about is if your schema is getting overridden, if a column is being deleted, if your AI removes a column and your column has essential data, once the data is lost, you cannot recover it forever. Like it's gone. So that's why you need to be very careful before you implement or execute any schema level stuff. You need to be very clear and explain, look, don't delete any data sometimes. But this might only happen when your application is super complex. There are lots of things happening. But for simple things, it should pretty much know what it's doing.
Okay.
Yeah. Okay. So what I'm doing right now is, so what happened, the issue that I'm facing right now is there were different commits that Lovable did, and the cart functionality through Supabase, it already committed it. So that code is also in GitHub, so I'm not able to demo this to you. So I'm just gonna go back to a previous commit, add grocery cart paste. This is the commit 18 minutes ago. This is the one that we want before we went to connect it to Supabase. So I'm just gonna copy this hash, and then I'm going to go into Cursor, and then just say jump my head to this commit. So you can just simply say that, and it will just jump to that version of the app. And it's so simple. And I will have the version without the Supabase integration. This is actually a pretty cool feature that you have with version history. So if I go here and I see localhost 88, I can see the same application. Now, when I add this to cart and refresh, you shouldn't see that anymore. See? So yeah, we are jumping back in history and we're going to a previous version. This is how you can keep coding without losing or worrying about if your code got overridden and now you cannot go back. It's as simple to go back in version. Okay, so now how do we do this with Cursor? So we spoke a bit about MCPs, right? So MCPs are how your cursor talks to any application. So now we want cursor to talk to Supabase. So we need to create a basic MCP setup. So in cursor, there is now an easier way to do this. You can just create .cursor/mcp.json. So you just create this JSON file within your project directory. And what you need to do is just go and say MCP cursor Supabase. So just Google it and you will get the code for doing that. So if I click on this and I click on cursor, there's this code. You just have to copy this code, go and put it over here. And you still need to do a couple more things before you're able to go with it, right? So one is I'm going to remove this read only, because read only is a flag that by default they've written in the example so that we don't write to the database. We don't modify the database. So in our case, we are going to write. So I'm going to remove this flag. And we need two more things. We need a personal access token and we need a project reference. So for the project reference, it's easy. When you're in this is your table. In the URL, you'll see this long string. So you can just copy that string. Between project and editor, there's this long string. You can copy. There are multiple places where you can pull the project reference, but this is the simplest way, and just go paste it here. So your app knows that this is the project it needs to be talking to. Then you need the access token. So this access token also is not very hard. You just go here, and then I think it's somewhere over account preferences. Yeah. If you go to account preferences on the top right over here and say account preferences, you have this thing called access token. Just create a new token and just say cursor, and then you just generate a token. So this is like the key for your cursor to talk to Supabase. So when I put the access token, now it has access to talk to your database. One thing you need to do, unfortunately, in cursor is once you create an MCP, you have to once close it and restart it. It's just a one-time thing, but once you do that, it picks it up. So now your MCP is connected. How do you check if it's connected? You can just go into your AI and you can ask directly, can you talk to my database? We are just testing if your AI can talk to your database. That's all we're doing right now. Okay, to be a little more specific, using MCP. It didn't help you connect to your database. I'll need to understand what type of database. I'm just going to use Glock4. I have MCP enabled. Check if you can talk to my database. See, it's now figured out all the different MCP options available. And now it's listing all the tables which is already there. See, so it already pulled from my Supabase that there is a database contains cart items table with the following structure. See, so Supabase, so your cursor knows what tables exist. So I can literally do everything here. But if you just one thing to notice, right? So why did it work when we changed the model? And why didn't it work when we had on auto is an important thing for you to just understand. Because when we use auto, it's using the models built by cursor. When you use Claude 4 Sonnet, it's using the model built by Anthropic. So Claude 4 Sonnet is the smartest model. It gets things. Your other models are all just average at most. Sometimes it gets it, sometimes it doesn't. Yeah, anyway. So you know that your cursor is talking to your database. Then it's very simple. Now it's the exact same process as you did in your Lovable. You can even do things like delete my table for now, so that it's just deleting this entire thing, and then we can create it again. So it's I'll delete the cart items table. And now if you go back into my Supabase and I refresh, okay, let me go back to dashboard. And if I go to my table editor, I see no tables here, right? I think the URL was linked to a specific table. So yeah, if I go to my table editor, you'll see absolutely no tables because we just deleted it. Now I can create it again. I can be when I add, just need to use the same exact prompt. I can even copy it from Lovable. So simple page, we said something like create a schema for storing the items and add items. This application will not require authentication. Achieve this using MCP. So I'm just adding this one line extra to be very clear that otherwise what it'll do is it'll give you an SQL code and it'll say, go do it yourself. Sometimes this happens, but when you say achieve this using MCP, it's so much easier. You're just giving it permission to go do all the things on its own, basically. And you'll pretty much get the same benefit of this. So you will from this point, so right now it doesn't do anything, but when it's done, you'll be able to keep items in the cart in the database, and when you refresh, it won't go away when you run the application. So right now you refresh, it goes away, but let it finish. And also another nifty feature on Cursor is like you can queue instructions. So I'm assuming that it will do the same issue that Lovable does, so that when I refresh, it won't just pull the items, it will just add it to the cart. But I will also write a thing saying when I refresh the page, fetch items from the cart, then fetch the cart items from the database and show it in my application, right? So I can just queue it. So it will automatically wait for this to finish, and then it will go do the next task. And this is pretty cool on Cursor, that you can queue a lot of tasks up front, then you go watch TV or do whatever you want. And when you come back, you'll find your application done. So it's literally, you can like multitask. And I also made a video on how you can use Claude Code. That's even crazier. The chances of errors on Claude Code is even lower than Cursor. So you can like literally have 5-6 windows and define what tasks you need to do for each window, and just go do your own thing. When you come back, your app will be ready, which is this is such an interesting way to build things nowadays. Yeah, so this is going to take a little time because it's like creating all the utility functions only for the first time, it's creating all these utility functions to talk to Supabase and all of that stuff. You wouldn't have to worry about, this is only a one-time thing. Then from the second time onwards, because those utility functions are already there, it will take much faster, but it'll do all of this, and you should be able to see your functionality up here. Yeah. Any questions so far? Was this clear on how we are using databases and what we are using it for?
I think I got the idea down. Yep.
Okay,
Do have a question about server. For example, like you said, typically the client talks to the server, talks to the database, and then that's how data is retrieved. I haven't quite understood why that is, because I think when you mentioned it was more so that it serves you the right thing. But is the request from the client not clear enough on what the right thing is? Or maybe I misheard it. I'm not sure.
Yeah, it's just a better way to organize all your services. So there are, in companies, sometimes services are owned by different people, right? So there will be like, for example, my entity, like Delivery Hero as an entity owns a specific service. And then there will be another brand within Delivery Hero that owns a different service. So now, like, this service maintains that logic of what to serve and what kind of requests are coming in. They also do more things on top of it, like tracking, like how many requests are made, how many requests are failing, what is the load volume of each request. They track all of this, so they can monitor like costs, they can monitor like the traffic, they can monitor like failure rates and decrease failure rates. There are lots of benefits you get in having all of this middleman. And also, even if you're like a smaller application, you don't have to worry about what database schema it needs to think about. You don't have to worry about those things. You always know that your server will independently do its job of talking to the database. So this layer, you set things up once, and then you don't worry about it at all. You set this logic up once between server and database in a way that regardless of what input you ask, it will figure out how to fetch from the database, right? Because sometimes you want to fetch only the user. Sometimes you want to fetch only the user preferences of a user. Sometimes you want to fetch like multiple things related to a user. So how you want to fetch information from a database could keep changing. So if you have to write all this logic, when I want to fetch user, follow this function. When I want to fetch like only preferences of a user, follow this function. So you're going to be writing all of this each time in each part of the code you're building in your application. So let's say you want to fetch only the user preferences on the home screen, and then you want to fetch the user preferences on the checkout screen. So in each time you would be writing that same piece of code. So where do you unify all that code? You put it in one place, and that place is a server, basically.
Okay. Yeah, makes sense. Thanks.
It's just a better organization. And usually in companies, there are teams working on one service. So there'll be like a service, say image service is an actual service. So image service is just responsible for serving all the images that is in our application. And this image service team, they take care of how big the images are, how much image requests are coming from all over the world. This is like millions of requests per second. And they take care of like how many, like what's the traffic balance like between different regions, how much cost are we incurring for this sort of traffic load, how can we reduce cost. So they work only on the application layer, and there are engineers who work only on the database layer. So as your company grows, you need this kind of a model to scale. For smaller things, this works. Like we just did this direct.
Yeah.
Yeah. So let's see. I think as per what cursor says, it should be done. So refresh. See, there you go. It works. I add more things to the cart and then I add it. So there you go. Yeah. This is how you work with database and cursor and Lovable. It's a one-time setup, right? So you don't have to keep doing this each time. So once you set it up, everything is good to go. Okay. So I think, yeah, today's was, as I said, like pretty short session. So we did a Supabase demo. Okay, just a couple more like tips. When do you make database calls? There are like usually ways you can approach this. One is on page load, and the other one is when you interact with an element, right? When you click on a button, when you add something to the database, when you add something to the cart, for example, that's what we did. So these are typically when you load, like when you make database calls. There's like a pro and cons to each, right? And this is critical on the user experience side. So when you do something on page load, your page takes longer to load because your page will not render until the data is fetched from the database. So if the database takes longer to give you the data, or the internet is slow and it takes time for the data to make it from your database to your app, then your app will be slow. That's why you see slow apps. Okay, because your data is taking longer to go from the database to your application. That basically happens. There are some information you need to load on page load. Like for example, the whole like first viewport data, right? This is something you have to load on page load because we don't want to show an empty screen to our users. There are some information you can load on a button click. For example, what happens when you click on a button in the home page that goes to the second page, you don't need to load the second page data when you're on the first page. So what you can do is on the click of a button, you can load the second page data. Or I go to the second page and on the load of the second page, I can load that second page data. So you can decide when you want to make the database calls. If you don't specify it, AI will assume. AI will typically just load it on page load. But if you say, oh no, you know what? I want the second page to load like super quickly and I don't want that page to take time. You can be like, when I click the button on the first page itself, make the database call, get the data, then open to the second page. You can define something like that. So your user experience could change because now if you click a button on the home page, you'll put a loader or something in the home page itself. And when the data is loaded, you'll make a neat transition. That would be if you configure it on a button click. If you configure it on a page load, from the first page, it'll go to the second page, it will load in the second page, and then it will display the data. That's all it is. So it's just how you want to define the user experience is very linked to how you do your database calls. Okay, simple, just whatever you learned to try it out in your use case, how you can connect it to a database, experiment with different database triggers, decide when you want to store it into the database, right? So if you want to store it right when the user interacts or when they go from one page to the next page, it's up to you. Yeah, and again, document what you learn. These things are going to, you'll understand, okay, what did I do wrong? For example, I documented right now to explain to you that when I don't say use MCP, it doesn't do that. Or when I don't say I don't need user authentication, it assumes it will throw an error and it assumes that user authentication needs to be there. So these are the things that you tend to take away from documentation, that you're more aware of how to get these things done without issues. Some tips: load all the essential data when loading the website. Only the essential ones, don't load everything. So if you load the entire database in your first load, your app is going to be super slow. So you want to be clear on what level of data you want to load. You create loading states while database calls are made. This is why all designers, we spend time creating loading states for every screen. Progressively avoid to downloading large amounts of data at once. This is a big red flag, right? When you have too much data that you want to load at once, you might want to, it reduces speed, it spoils the experience, it's just not secure, and like it's just so much. It also incurs a lot of charge if you're like using a lot of traffic. Right now it's free, Supabase manages this, but when you're having a huge application and lots of users come, if you're downloading large amounts of data at once, you're going to incur a lot of charge. So you might want to think about how to optimize how you talk to your database in a way that's like lean and just what you need. Yeah, that's the quick intro to databases. I hope this is enough information for you to just figure out how to create your application. Just put it on school and I'll answer like your specific project related stuff. But yeah, for all your applications, I think whatever you have, you should be able to store with this basic understanding. Yes. Yeah, that was it for today. Any questions, anything?
I do have one. I keep asking so many questions. Others can jump in as well if someone has any.
It's all good.
So let's say you have a page where there's like a filter, right? I would assume that there is a table which has like all of your items, all items possible that can be displayed in the website. And then
Mhm.
filtration is basically showing some items from this massive table of items that we have. So there has to be, that there is some sort of code, some sort of logic that decides what's being pulled. So is that code based out of what we just learned so far? Is that code served in a server? Is that where it happens?
Good question. I guess I should have also covered this in my deck. So it happens when you make the request. So when you make a request to the database asking for data, you will, in the request, you will specify, I want for this user ID, I want show the first 20 results. I want with these additional filters. You specify in the request, and Supabase will return only those data. So you wouldn't like fetch all of it and filter it in your client. If you fetch all of it and filter it in your client, you'll end up with that issue of loading large amounts of data at once. So you might want to, when you make a request, you will say, if you want to like think about optimization, you will ask your AI, like, how much, what are you requesting right now? Don't request all of it, just request this much. So you can be more mindful of what data you pull. And you know that when it's requesting, in that requesting code, you specify what you want to be requested.
Okay. But I guess, so sure, in our case, right, small scale, directly Supabase, yeah, sure, it returns whatever. But let's pretend it's a bigger company or whatever, and there is a server in between, right? And you request for that, or does your request include the filter, like you said? Is it still the same thing?
Yes. So you send your criteria from the client to the server. The server forwards that criteria back to the database, and it gets that information. So what we need to be very careful is how the information between the database and the server. So the data coming out from the database is the most important thing. So we specify all the filters either at the client side or also on the server side.
Okay.
So we have to be careful about, okay, let me open my diagram to show you clearly. So you would specify what data you need over here, right? Only the data you need. You would put all your filters, everything in the client, and you pass it to the server. What that server will do is understand you only need these things, and it will create a request from here to the database with your filtering. So your server would have been defined in a flexible way that it accommodates your filtering logic. So it will accommodate your filtering logic and ask for only those filtered data which flows from the database. What won't happen, this is not how, like what will not happen is that the server gets all the data from the database and filter it and then send it to you. That's not how it works. That's inefficient because you're sending large amounts of data between database and server, which is a no-go. You should always send very little data from your database, just the data you need.
Okay, got it. Yeah, thanks.
Yeah, was it too technical otherwise, or was it simple to understand, like just the fundamentals? Yeah.
I thought it was very interesting to get more information also how the database is working and how the front end, like the difference between that.
Yeah, thanks, Karan. Thanks for the feedback. I think this will also help you talk to your engineers better in your companies, even as a designer, even if you don't write code, you know exactly what's happening. So you can talk to your backend engineer. If your backend engineer, if your app loads slowly, you can talk to your backend engineer and ask, hey, why is this happening? Can you explain this to me? And you can suggest, and you can think about your user experience. And in that consideration, you can suggest your engineer. That helps you become a better designer in general.
Yeah, it definitely helps to know.
Question. So
yes,
you made a file, right? A file specifically for MCP within Cursor, and you named the file a certain way, like #/ whatever. What was that? Can you just drop that in the chat?
So the folder name is called .cursor, and the file name is called mcp.json. So you can create, the faster way to create is you say create new file and just say .cursor/json. It will make the same thing basically.
Slash is basically like folder and then files.
It's like a shortcut for creating a subfolder, subfile or a subfolder. Yeah. If you say .cursor/rules/ say always.mdc, for example, it'll create a .cursor folder, then it'll create a rules folder within .cursor folder, and then put this file inside the rules folder. So it's a shortcut.
Okay.
Yeah. Any more questions?
I don't have any more questions. I'm gonna shut up.
No, please ask questions. I think questions is how we can clarify things, and that's the whole value of doing it in a live session. Yeah. And yeah, of course, please, if you have more, put it on school, and I'm definitely answer it as quick as I can. Yeah. Cool. I think that's it for today. Thanks for sitting with me, and we'll meet again next week for the authentication part. It's just one layer on top of it'll also be a short session because we already learned how to store things in the database. So I'm just going to show you how to store user information in the database and retrieve it, and where we're going to store that user information. That's it. Quite simple. Okay, cool. Then enjoy your weekend and Friday, and see you all next week.
Thanks. Bye.
Thank you.
Bye.